In this video, we're going to talk about peak oil theory. And we're going to start with, of all things, peanuts. I want you to imagine that you're eating a very large bucket of peanuts. And these peanuts are shelled, so they're in the shell, and what you have to do is crack the shell open, you have to take the peanuts out, and then you'll discard the empty shell and leave it back in the bucket. Now, the more you do that, eventually you're going to get to the point where over half of the bucket will be just empty shells. And that makes it that much harder for you to get at the peanuts. So the peanuts will cost you more effort, and it will be higher perceived value for you because it's going to be harder work to get those peanuts. That's kind of what peak oil theory is like. That same principle, says the peak oil theory, applies to oil wells. The first part of an oil well, it's pretty easy to get the oil out. It's pretty accessible. It'll come flowing pretty quick. But eventually, you'll be over half full. It'll be half empty, rather. And the remaining oil will be harder to get. And then you're depleting the oil that much rapidly. Eventually, you get to the point where there's none left. And each oil well, individual oil well that is drilled, will follow a similar curve. And this was theorized by Marion King Hubbert, M. King Hubbert. And he called this the Hubbert curve. That if you looked at the sum of individual wells who all had a similar curve, they would have a huge exponential uptick in productivity, then they would plateau a bit, and then they would really start to decline in production as the oil got tough to get. Eventually, if you added up all those individual wells across the planet, you could aggregate them into one giant productivity curve, and eventually there would be a point for the whole planet at which we would have consumed more than half of the available oil. And then it would be diminishing returns from then on, and we would be gradually running out of oil. Now that led to his peak oil theory, that we could forecast the proven reserves that were available on the planet, and we could forecast into the future a point at which we would hit peak production. Then, we would see a bunch of things happen. The price of oil would skyrocket. We would need to shift away to other things, and the economic system that we run under would really be in jeopardy because oil pays such a big part of it through transportation and shipping and just plastics and consumer culture in general. So we rely so heavily on oil that when we reach that point, it would be highly detrimental to our economy. Now that point was predicted to be somewhere around the year 2000, then revised to about 2015. So have we hit it? Or does the theory not really hold? And that's an important question. Is there evidence to support the peak oil theory? Well, it depends. One important facet of this is that it accounts for proved reserves, proved or proven. You'll hear both of those. Proved sounds kind of funny, but that's the language that a lot of oil companies use, but I'll call it proven reserves. What do we mean by that? Well, it's quantities of petroleum that are anticipated to be commercially recovered. That's a definition of proven or proved reserves. Oil companies and exploration companies have to report on this. They need to be accurate, otherwise they'll get sued by their shareholders. They'll lose millions of dollars. So it's important for them to get that figure accurate. So when we add up all of those figures, we can get an idea of the planet's proven reserves. To be proven, they have to have an over 90% chance of being present. So you can't just guess. You get charged for fraud and deceiving your shareholders. So, for example, if an oil company believes that there's a good chance of successful drilling, they might classify those as proven. The other alternative would be unproven or probable. So they might, if they're not sure they could get them out because they're in a weird spot and they might not have the right technology, then they could call it unproven or probable reserves. Commercially recovered is a very key phrase as well. What does commercially recovered mean? Using existing equipment under existing operating conditions. Let's illustrate that. So let's say $20 a barrel is the going price for oil. Under current technology, you've got an oil well somewhere in northern Alberta. you could pump it out for $10 a barrel. So for you, that's profitable because you'll make $10 a barrel in profit. So that's using existing technology, very easy for you to get out of the ground. There is lots of oil in shale rock. Now you could get that out, but it would cost $50. It would cost you $50 to drill it out, and you could only sell it for $20. So therefore, you wouldn't count those as proven reserves because they're not commercially recoverable with existing technologies. So when we look at proven reserves, we're not looking at all the oil that's there, we're looking at all the oil that we can get out at today's technology. And it doesn't always account for an increase in price or an increase in technology, because both of those things could make this shale oil accessible. For example, if the price of oil decided to skyrocket and different global demand patterns or geopolitical factors cause the price of oil to rise to over $50 a barrel, then this shale oil would be profitable. And so then the planet's proved reserves would increase. So anytime we're talking about proved reserves, we have to think about what is the current technology, what is the current price of oil. Because if either of those change, that will also change the proven reserves.